Okay, so you sent over some really interesting documentation about Java switch statements.
Yeah.
It seems like you're trying to get a handle on how they work, especially in a real-world situation. You even included a currency converter example.
Right.
Nice.
It's great that we have a concrete example to work with.
Yeah,
Sometimes those abstract programming concepts can feel a bit fuzzy until you see them in action.
absolutely.
Yeah.
So we've got this question and solution document
Okay.
that lays out a currency converter using, get this, nested switch statements.
Wow.
I'm already intrigued.
Yeah.
But before we get ahead of ourselves,
Okay.
let's make sure we're all on the same page about the basics.
Sounds good.
Okay.
Let's break it down.
Okay.
Think of a switch statement as a streamlined way to make decisions in your code,
Mm-hmm.
instead of a bunch of if-else blocks.
Yeah.
A switch statement lets you neatly compare a value against a bunch of different possibilities.
Okay. I'm following so far.
Yeah.
So how does this all play into our currency converter?
Well, in this case, the value being compared is the currency the user wants to convert.
Okay.
The question and solution document shows how nested switch statements create a hierarchy of choices.
Right.
Just like those old school phone menus, press 1 for USD, 2 for EUR, and so on.
Ah, I get it.
Yeah.
So the first switch statement figures out what currency you're starting with.
Right.
And then based on that, another switch statement pops up to let you pick the currency you want to convert to.
Exactly.
Okay.
And this nested structure makes the code surprisingly efficient.
Go ahead.
You're not checking every single currency combination all at once, just the relevant ones based on the user's initial choice.
Smart.
Yeah.
So less work for the computer
Right.
and a smoother experience for the user.
Exactly.
Everyone wins.
Now, there is one little detail that can trip people up.
Okay.
The break statement.
Uh-huh.
Each case in a switch statement needs a break at the end.
Right.
Otherwise, your code might keep running into the next case, even if it's not the right one.
Okay. That sounds important. So break acts like a stop sign telling the code, hey, we found the right case. Let's stop here.
Precisely.
Got it.
Without it, you could end up with some seriously wonky conversions.
Yeah.
Imagine converting USD to EUR and then accidentally converting it again to GBP because the code kept going.
Yikes.
Yeah.
Yeah. Those break statements are definitely our friends.
Right.
So we've got the basic idea of a switch statement down,
Mm,
and we see how they can be nested to handle multiple choices.
right.
I'm itching to see how this all comes together in our currency converter example.
Let's dive into the code.
Okay.
The question and solution document actually provides the complete Java program for the converter.
Okay.
It starts by welcoming the user and presenting them with the main menu.
Okay.
Simple enough, right?
Totally.
Yeah.
It's setting the stage for the conversion process.
Exactly.
Okay.
Then it uses something called the scanner class to read the user's input.
Okay.
So if they type 1 for USD, the program knows what they want to do.
The scanner's like the program's ears.
Yeah.
Listening for the user's instructions.
Right.
Okay, what happens next?
This is where things get interesting.
Okay.
The program uses a do-while loop to keep
Mhm.
running until the user decides to exit.
Hmm.
Inside this loop is our first switch statement,
Okay.
which evaluates the user's choice from the main menu.
I'm ready for the choose your own adventure part.
You got it.
Okay.
Each case within this switch statement corresponds to a specific currency the user might want to convert from.
All right.
For example, if they chose USD, the code would jump to the block associated with the USD case.
And that's where the nested switch statement comes in, right?
Exactly.
To handle the two currency selection.
It's like opening a submenu.
Okay.
The user gets to choose whether they want to convert their USD to EUR GBP or go back to the main menu.
Okay, this is starting to make a lot of sense.
Good.
So we've got the outer switch handling the from currency.
Right.
And then for each from currency, an inner switch handles the to currency.
Yeah.
It's like a decision tree.
You got it. And it's this nested structure that allows the program to handle all the different currency combinations in a clean and organized way.
Okay.
It's like having a mini program for each conversion path, all tucked neatly inside the main program.
Brilliant.
Yeah.
So what happens after the user selects both their from and to currencies?
Okay.
Does the magic happen then?
You bet.
Okay.
The program then prompts the user to enter the amount they want to convert.
Okay.
Let's say they want to convert 100 USD to GBP.
Okay.
The program would read that 100 using the scanner and store it in a variable.
Okay, so now we've got all the pieces.
Yep.
The from currency, the to currency, and the amount time for the actual conversion.
Absolutely.
Yeah.
The program uses predefined exchange rates for each currency pair.
Okay.
So in our example, it would look up the exchange rate for USD to GBP.
Okay.
Let's say it's 0.75 for simplicity.
And then it just multiplies the 100 USD by 0.75 to get the equivalent amount in GBP.
Exactly. The calculated amount, which would be 75 GBP in this case, is then stored in a new variable and displayed to the user.
Voila, instant conversion.
That's pretty cool.
It seems like nested switch statements are a really efficient way to manage this kind of multi-step process.
They are. And remember, this is just one example.
Right.
You can use nested switch statements in all sorts of scenarios where you have multiple layers of decision making.
This is fascinating stuff.
Yeah.
We've gone from the basic idea of a switch statement to seeing it in action within a real program.
Mm-hmm.
I'm excited to dig deeper into the code and explore the nuances of nested switch case structures.
Let's do it. Welcome back. I think it's time we take a closer look at the heart of our currency converter,
Okay.
the nested switch case structure. It's doing a lot of heavy lifting behind the scenes.
I'm all ears. It's clear these nested switch case statements are what make this whole converter tick.
Exactly. Think of them as a series of checkpoints,
Okay.
guiding the program through different choices. The outer switch statement, like we discussed, handles the from currency, USD, EUR, or GBP.
And each of those choices leads to a nested switch statement that handles the to currency.
Yeah.
It's like those nested Russian dolls, each one containing a smaller version of itself.
That's a great analogy. And the beauty of this nested structure is how closely it mirrors the user's experience.
Right.
When you're using a currency converter, you naturally think, okay, I'm converting from this currency to that currency.
It's like the code is designed to follow the same thought process as the person using it makes sense.
Exactly. It's not just about making the code work. It's about making it logical, readable, and user-friendly.
So if we crack open this nested structure, what do we see?
Okay.
What's happening at each of these decision points?
Remember those code snippets we saw earlier?
Yes.
Those were just random examples. They were the actual building blocks of our currency converter.
Okay.
Each case within those nested switch statements tells the program what to do for a specific pair of currencies.
So when the user chooses, let's say, USD to EUR, the code navigates through those nested switches,
Right.
pinpointing the exact formula for that specific pair.
Exactly. It's like having a highly specialized lookup table where each possible currency combination has its own dedicated code tucked away within those case blocks.
It's amazing how something as simple as a currency converter can have such intricate logic behind it.
Right, and that's the power of nested switch case structures. They can handle surprisingly complex decision-making in a way that keeps the code clean and manageable.
So we've got these decision points, but what happens if the user throws a curveball?
Okay,
Like what if they enter an invalid choice?
good question. That's where those default cases come in.
Yeah.
Remember we talked about those?
Uh-huh.
They act as safety nets within each switch statement.
So if the user makes a mistake, the program doesn't just crash.
Not at all. Instead of crashing,
Yeah.
the program will display a message like invalid option and guide the user back to the appropriate menu.
That's a relief. It's like having a built-in error handling mechanism within the decision-making structure itself.
Precisely. Now you might be wondering,
And-
couldn't we just use a bunch of if-else statements to do the same thing?
Yeah, I can see how that might work.
Mm-hmm.
But wouldn't it get messy really fast, especially
Mhm.
with all the different currency combinations?
You're exactly right. As the number of choices grows, if-else chains become a tangled mess.
Yeah.
Nested switch case statements offer a much more elegant and manageable solution.
So they're not just about functionality, they're also about keeping the code organized and easier to understand, right?
Absolutely.
Yeah.
That's why they're such a valuable tool, but like any tool, it's important to use them wisely.
Okay.
There are situations where nested switch case structures might not be the most efficient option.
Like what?
Well, imagine if the number of currencies in our converter kept growing, or if the exchange rates changed frequently.
Right.
Updating that massive nested structure could become a real headache.
Yeah, I can see how that could get out of hand quickly.
Exactly, and that's where alternative approaches like those mentioned in the Bildung article might be a better fit.
Oh.
Things like polymorphism or design patterns like the command pattern.
So it's like having different tools in your programming toolbox. You wouldn't use a hammer to screw in a screw.
Right. That's a great analogy. It's about understanding the strengths and limitations of each approach and choosing the right one for the job.
Makes sense now. Before we move on, can we circle back to something the Code Mentor article brought up?
Sure.
It mentioned hash values being used when comparing strings within switch statements.
Oh, that's a great point. It might seem like a technical detail,
Okay.
but it's actually pretty important for understanding how Java handles string comparisons.
Okay. Lay it on me. What are these hash values all about?
So computers think in numbers, not letters.
Right.
When Java encounters a string in a switch statement, it needs a way to convert that string into a numerical representation.
Oh.
That's where the hash function comes in. It creates a kind of numerical fingerprint for each string called a hash value.
So it's like giving each string a unique ID number that the computer can easily work with.
Exactly. These hash values make comparing strings super fast and efficient.
Okay.
But there's a catch.
Oh.
Sometimes different strings can accidentally end up with the same hash value. This is called a collision.
Oh, that sounds like it could cause problems. Does Java just throw his hands up in the air when that happens?
Not at all. It's got a backup plan.
Okay.
To resolve collisions, Java doesn't just rely on hash values. It also uses a method called equals to double-check whether the strings are truly identical. It's like a two-step verification process.
So it's a combination of fast, efficient, hash-based comparisons and precise string matching to make sure everything is accurate.
You got it. And this understanding of how Java handles string comparisons is crucial when you're working with switch statements, especially when those choices are based on strings.
It's like peeking behind the curtain and seeing the intricate mechanisms that make these seemingly simple operations work pretty cool.
It is now. Are you ready to dive into the actual code from the question and solution document and walk through how these nested switch case structures are implemented in our currency converter?
Absolutely. Let's do it.
Welcome back to our deep dive into Java switch statements. We've covered a lot of ground, from the basic mechanics to seeing those mechanics in action within a real currency converter program.
It's been quite a journey. And speaking of journeys,
Yeah.
I'm curious to explore how switch statements themselves have evolved over time.
Okay.
I know the Bildung article mentioned something called switch expressions.
Yes, switch expressions.
Yes.
They were introduced in JDK 13 and offer a more modern and concise way to use switch statements.
From what I gathered, they're especially handy when you want to directly return a value.
Exactly. Think of them as a streamlined version of the classic switch statement. They ditch the colons and break statements, opting for a cleaner syntax using arrows.
So it's like a code makeover, everything's more compact and readable.
Precisely, and this cleaner syntax has a bonus. It actually helps prevent errors.
Oh, yeah.
Remember how we talked about those accidental fall-through cases where the code keeps running into the next case, even when it shouldn't?
Right.
Switch expressions eliminate that risk entirely.
It's like they've built in guardrails to keep the code on track. Very cool.
Yeah,
So can switch expressions do everything regular switch statements can do?
that's a good question. While incredibly useful,
Yeah.
they do have their limitations. Traditional switch statements are still the way to go when you need to execute multiple lines of code within a case. Switch expressions excel when you need to quickly and cleanly return a value based on a condition.
So it's not a case of one being better than the other, but rather choosing the right tool for the task at hand.
Exactly. And as you become a more experienced programmer, you'll develop a feel for which tool is the best fit for different situations.
Now, before we wrap up,
Okay.
I want to revisit something the Bildung article mentioned.
Mm-hmm.
It cautioned against overusing switch statements, especially when dealing with a lot of choices or situations where those choices might change a lot.
That's a really important point. While switch statements are great for a predefined set of options,
Yeah.
they can become cumbersome if things are constantly changing or if you have a huge number of cases to deal with.
So it's like trying to fit a square peg into a round hole.
Exactly.
Eventually, you need a different approach.
For those more dynamic scenarios, the article suggested looking into things like polymorphism or design patterns like the command pattern. These techniques offer more flexibility and adaptability when dealing with complex or constantly evolving requirements.
It's like recognizing that sometimes you need to build a bridge instead of a ladder to get where you want to go.
What a great analogy.
So as you continue to learn about Java and switch statements, remember that there are always different tools and approaches available.
Right.
Understanding these alternatives will make you a more well-rounded and effective programmer.
Absolutely.
This has been an amazing deep dive.
Yeah, it has.
We've gone from the basics of switch statements all the way to exploring advanced concepts like nested structures, string comparisons, and even switch expressions.
And we've seen how these concepts come together in a practical example, our currency converter.
Right.
It's proof that even seemingly simple programs can utilize some pretty sophisticated programming techniques.
I feel like I've gained a whole new level of understanding about Java and switch statements.
Good, I'm glad.
And to our listeners, we encourage you to keep experimenting, keep learning, and never be afraid to try new things. The journey of a programmer is one of continuous discovery.
And who knows, maybe you'll be the one to come up with the next revolutionary programming technique. Until then, happy coding.